Okay, welcome back to Intermediate Algebra, section 3.3, equations of lines. So now we're going to learn how to write equations for these lines. So maybe we'll be given a line, maybe we'll be given some information about the line, but we want to be able to come up with equations. So the first one we're going to look at is what's called slope-intercept form. Now, if you've done anything with lines before, this is probably the one you might remember, and it was almost certainly your favorite because this is the one people usually like. So we have y is equal to mx plus b. So let's go through this real briefly and see what these pieces are. First, m, as I hope you would expect since we used it for slope before, m is the slope. So that's going to be the first thing. If you know the slope, it always goes right there. B is our y-intercept. Why is b the y-intercept in this form? Well, I'm glad you asked. It's really pretty simple. Remember, if you want a y-intercept, you plug in 0 for x. Well, if you look at this equation, if you put in 0 for x, you just get y is equal to whatever b is. So b is always that y-intercept. Finally, and this is really important because people make this mistake frequently, x and y are the variables. Let me repeat that. X and y are the variables, which means when you write this equation, x is always going to be there, y will always be there. Do not put usually the most common mistake here is that people put the y-intercept in over here for the y instead of for the b. You don't want to do that. Okay, x and y are the variables. Remember, x and y are where we would have our ordered pairs that we would plug in that would make the whole thing work. So we need the variables. Please don't get rid of them. Keep them there. So case in point, here's my first example. Write the equation if the slope is negative 2/3 and the y-intercept is 4. Well, I'm just going to take the slope, negative 2/3, and I'm going to put it in for the m. There it is, negative 2/3. I'm going to take my y-intercept of 4 and put it in for the b. And then notice I still have x and y. Please don't put the 4 over here. I see it happen a lot. I have to mark it wrong when people do it. I don't like it, so please don't do that. All right, the other thing I want to mention here briefly is this. When we have slope-intercept form, or any time really that we have any given point and a slope, we can make a line, we can graph the line without bothering to come up with any ordered pairs. So quite simply what that means is this. Since my y-intercept is 4, that's a free point. I already know that that point is on the line. It's the y-intercept, so I put that dot on the y-axis. So then I take the slope, the negative 2/3, and I use it as directions to another point. Okay, the slope tells me how the rise and run compare, and so I'm going to start at my y-intercept here, that point that I already had, and since my slope is negative, I'm going to go down 2, there we go, and then I'm going to go over 3. Now, I like to always if it's negative, I always like to go down, but I always go right because that way my line ends up going the right way. Please note, a negative slope line goes down from left to right. A positive slope line would go up. So make sure your lines are going the right way. So down 2 and then over 3. And that's my second point, and I can make the graph. And so it actually works out really well. All right, let's get another board up. Okay, so continuing on, I wanted to do this problem. Write the equation in slope-intercept form. So the equation I'm given is 7x minus 2y is equal to 16. That's not slope-intercept form. Remember, slope-intercept form, the y is by itself. That's really the defining characteristic. We certainly don't have y by itself. So what this problem is really asking us to do is to just rearrange it, solve for y. So I do that. I subtracted 7x from both sides. Now, I put the negative 7x in front of the 16 because I want this to end up looking like slope-intercept form, right? mx plus b. So I put that in front. And 16 is still positive, so it has a plus sign. And then I divide both sides by negative 2. Now, when I divide by negative 2, remember I can just divide both of those parts by negative 2. So I take negative 7 divided by negative 2, which is a positive 7/2 x. And then 16 divided by 2 gives me the minus 8. And then from that, I can tell, hey, my slope is positive 7/2, and my y-intercept would be a negative 8. And if I needed to graph the line, I could. I'm not going to right now, but if we wanted to, we could. Okay, that brings us to the other main form for writing the equation of a line. There's a third one in the book. It's called standard form, but we're not going to do it. So Pay attention to the directions on the homework assignment when you get there, if you're taking my class, because there are a couple problems that get skipped on this one. All right, anyway, point slope form. Y minus y1 is equal to m times x minus x1. Again, m is the slope. x1, y1 is any point that's on the line. Okay, and it doesn't even matter which one. If you have any point on the line, this is going to work. And last but not least, x and y again are the variables. Again, don't ever lose sight of that. These equations for lines, they always have x and y in them. Those are where we would put the numbers from our ordered pairs, not the point that we're actually using to write the equation. Okay, so make sure x and y stay in your equation. All right, we'll get some examples on the next board. All right, so I have a problem here with point slope form. Let's take a look at it. We want the equation line passing through the point -2, 4, and with a slope of a half. So I'm just going to write it out. Here's my equation. I filled in m. My slope is a half, so I put that in front of those parentheses. My x-coordinate is a -2, so you'll see I have x minus a -2. And my y-coordinate is 4, so over there I have y minus 4. I cleaned up the mess just a little bit, right? Subtracting a -2 is the same thing as adding 2. And there we go. That's the equation of my line. I'm done. I don't have to do anything else. This particular problem did not ask us to put it into slope-intercept form, for instance, so we can just leave it there. So we can do that with a point and a slope because that's what we were given. If I were given 2 points, I could still do it with point-slope form. But if I had 2 points, I would just have to find the slope first and then use either point, and it really actually wouldn't matter at all which one I used. All right, I want to look at this problem because this one's a little bit fun and it's going to bring something back that we just looked at in section 3.2. Write the equation of the line passing through 6, -4, and parallel to the line y equals 1/2 x minus 1. And we want this one in slope-intercept form. Now, a couple of things here that we have to keep in mind. I gave us a point. I did not directly give us a slope. So where is it hiding? Because we obviously need more than just a point to write the equation. Well, it's hiding in this parallel line. Remember, parallel lines always have the same slope. And so since the slope for this parallel line is a half, the slope for the line that I want also must be a half. So you'll notice that I took my -4 for the y. We got y plus 4. Remember, it's y minus -4, so it changes it to a plus. And then we have x minus 6. And I put the slope in. If these were perpendicular lines, remember I would use the opposite reciprocal. So instead of a half, I would have had a -2 there. All right, but unfortunately, this problem asks us to go just a little bit farther. It wants to answer in slope-intercept form. So I have to solve this equation for y. So the first thing I did was I got rid of the parentheses. 1/2 times x, and 1/2 times -6 is a -3. I then subtracted the 4 to give me the -7, and this is the answer that we actually want. So slope-intercept form ends up being unique, and so that's one reason why we like it, and because it just has so much good information sitting there staring at us. Slope, y-intercept, we really like that form. Okay, so pay attention to the directions. Sometimes we don't care what form the equation of the line takes, right? This one doesn't tell us what form we want it in, so we go, hey, we've got a point, we've got a slope, let's use point-slope form. Here we want our answer to end up in slope-intercept form, so we did that. But the key, though, is we didn't have the information we needed to start here, right? We were not given a slope, well, we were kind of given the slope. It was hiding in the parallel line. We definitely were not given a y-intercept. And so we had to go through the point-slope form to get to that slope-intercept form. So please be really careful with that. Have a great day. Thanks.